Hello everybody, I hope you can hear me well. I'm Moritz. Maybe I can also share my video, 1 second. Yes, hello. So maybe we wait a little bit longer, maybe 5 more minutes. So you can join either on the Discord, which allows you to ask also questions in voice chat, which might be nice if you like. Or if this is a little bit uncomfortable for you and it's easier for you to join via the YouTube link, then you can just join via the YouTube link. So we do basically both, so that you can choose which one is easier for you. Yeah, I think the live stream in Discord is a little bit ahead of time, and YouTube has a little delay. Yeah, if you want to ask questions, you can either ask questions in the chat, like in the text chat, or also I mean, I think best would it be if you ask the questions in the workshop test chat. Yeah, so more people are coming. Let's wait until 7:05. So just that we get everybody and nobody misses the beginning. Yeah, please, if you are in Discord, mute yourselves for now. Otherwise, I will have to mute you. Okay, I will mute some people. Yeah, basically, it's just that, we will have some sections where you can ask questions. Like I will make a stop after each section, and then you can ask questions. But but you should keep your mic closed because a lot of times there are just like some noises which are annoying for other people. Yeah, nice that everybody came today. Really cool. Hello, Edomone. Yeah, you shouldn't, or you can also like mute, basically deafen yourself, right? Which means that you don't hear anything, um, which is okay if you do it, so you can watch it on YouTube. Okay, let's wait 3 more minutes. Yeah, if you want to explore, you can look a little bit around our Discord platform. We chose to use Discord because the nice thing about Discord is that you can keep asking questions even after the event. You can ask questions in this workshop channel, and we can continue to communicate with that. You can also already check out now, maybe in the last 2 minutes until we will start. You can look into the other channels, maybe in the start channel to learn a little bit. Maybe say hi in the introduction channel. Yeah, you can check out like this Silo Development 101, which will basically a little bit what we're talking about today. Yeah, check out like the different channels and if you have a little bit of time, and later you can still after the workshop you can still keep engaged and ask questions, and maybe also like meet up with other people. Yes, I'm very happy that so many people joined already. If something is not working right, let me know. And always, if you have questions, you can put them in the chat, right in the workshop chat for any questions, and also in the YouTube chat. But it would be better if you do it in the Discord chat, because then this will be staying here, the questions, and we can answer them also like later, and this also helps other people. Okay, so it's basically 7:05, so I would say let's start now. Okay, I share already my screen. 1 second. Let me turn off the video now. Okay, yeah, thanks everybody for coming today. So we are talking about introduction to blockchain development, and in this short workshop, we will show you how to build a blockchain application. Obviously we don't have the time to go into detail, but this is a great starting point for everybody, just to first of all learn how they can write smart contracts, and then also on how to put them live on a decentralized application. We will look into what this means. So let's look into what we are doing in this workshop today. We will first have an introduction, maybe around 20 minutes, probably a little bit less. Then we will have a chapter about smart contract development. Yeah, you will know what smart contract development means in a second. I will explain that. But this is basically to write the contracts, like the code that is run on the blockchain, and then the app development, which is basically the code, like the front end code that can interact with a blockchain. So basically, yeah, your user interface where people can interact with an app that can communicate with the blockchain. So this is what we're talking today. This is the 3 different chapters. Yeah, I hope that each, like you already had maybe a look, you already know what blockchain technology is and maybe even did like the course on Dacade. I am from Moritz from Dacade, so we are building a peer-to-peer education platform, dacade.org. I will show you a bit later what this is. But yeah, we also have courses there, like an introduction course to blockchain. So I hope you already did that. This is more about the theoretical knowledge of blockchain technology. And I won't go into too much detail today, but because we want to focus more on the coding part and on the development part. So for theoretical stuff, I hope you already know that. We will just do a quick walkthrough, and this is what we are going to do now. So first of all, it's a question why you should learn about blockchain technology. So why do I do it? What is so interesting about it, right? So first of all, yeah, maybe we can look a little bit back on the latest technological trends. So like basically in the 70s, the personal computer got big, right? Around the same time also like internet, kind of the first internet applications became big, but it took like another 20, 30 years until like the internet really showed its potential, right? We cannot imagine like how great the internet is now. Like 30 years ago, nobody knew about that, but now it's like part of everything in our life, right? Like every business is an internet business. And after that, like maybe you all noticed that even a time when you didn't have smartphones, right? So like the next step, like basically in the 2000s was the iPhone moment where people were developing apps. And now basically everybody, almost everybody on the world has a mini computer in their hands, right? This was like unimaginable a couple of years ago. And with these apps, now like there are so many possibilities of people what they can do, right? And these are all like very important future technologies that impact our society so heavily. But the question is, obviously, this doesn't stop now. If ever, then I think it would accelerate the progress, right? Because now we can all communicate with people, and so new, very interesting technologies will be born. And so one of these technologies could be like AI, right? Artificial intelligence. Then there's biotechnology with CRISPR and gene editing, which is becoming very big. There's virtual reality, and then there's also blockchain. I think these are like the emergent technologies that probably really will change our future and will become very important, maybe as important as the internet or smartphones, if you look back a couple of years from the future. So why do we find this blockchain technology so interesting and think like this will be the thing that changes that has such a big impact on humanity? So why we think blockchain is so important is because it has basically it's the future of collaboration, right? So with the internet, we have a way to communicate with everybody on Earth, but like there is still a problem of collaboration, because in the past people were doing like how do you usually collaborate with somebody in another part of the world? Like usually in order to do that, if you want to make a company, you need to have lawyers and to create contracts, right? Nobody really trusts each other. So you have to have like either you have to have agreements with other companies where you basically just click on the terms of service, or you have to have lawyers and create kind of contracts how you work with somebody together. And this is like the great thing about blockchain technology, that maybe they can make these contracts obsolete and basically create a foundation of trust where you don't need this kind of lawyers who create, or notaries who create these kind of contracts, which would be very, very expensive, right? Like if for everything that you want to collaborate with somebody on the other side of the world and you want to work with them together, you need to create a contract for that. This like really hinders for people to work together. And so blockchain technology basically is a way to solve that, basically to create code that functions as a contract, meaning that you can collaborate with other people in the other side of the world and you can trust them because you trust that the code that is in this blockchain technology that is stored on the blockchain cannot be changed, right? So that it executes how it was built. And so this means that you can trust it and you can collaborate and use this as a fundament for collaboration. And this can spark like a lot of things, right? Like Bitcoin is one of these things that created, like it started over 10 years ago, and now basically there is a new form of money that has billions of dollars flown into it. So let's look into the Bitcoin blockchain. What is the Bitcoin blockchain? And as I said, I will go very high level here because most of you already know that, but I want to set the scope a little bit for you to know, okay, to get a little bit of the fundamentals so you understand what we're actually building. So the Bitcoin blockchain, basically what is stored in the Bitcoin blockchain, or to understand that, is first you have to understand the concept of a ledger. So because this is also something that comes up often that you read, it's a ledger. So what is a ledger? A ledger is basically just a book of transactions, or kind of a database of transactions, some form where transactions are written down, right? So like every time something is happening, this transaction is written down. So it's basically kind of a book of transactions where every transaction is noticed. And then the blockchain is basically also just a book of transactions of Bitcoin transactions that are happening. And so all of Bitcoin transactions that are happening, right? Like if in this example, Alice sends to Bob 2 Bitcoin, this gets stored in the Bitcoin blockchain, in this ledger of Bitcoin, a book of transaction of Bitcoin. And if Bob sends to Carl one Bitcoin, it gets also stored there. Alice to Dora, it gets also stored. So every transaction that ever happened are stored in this ledger. Yeah. And so basically the blockchain, this ledger of transaction, is then stored on every computer that is in the Bitcoin network. So every computer here has a copy of this book of transactions, right? And 1 second. Okay. Yeah. So basically, every transaction is, everybody who participates in this network has a copy of that. And the only way how you can enter new transactions in this book of transactions into this blockchain is like by something at Bitcoin that is called proof of work. And then you can add like a new block of transactions with kind of like a page of transactions that you can add to that. And so this is in a very, very difficult manner that we won't explain today, or actually it's not so difficult, but it's a little bit difficult to understand the concept. But basically the way how you can add new transactions into this book of transactions is kind of difficult, and you have to pay to do that. And because of that, it's very secure. And it's not one person who can change these transactions. It's just like if everybody agrees that these are the right transactions, this is what happened, then this can get stored and can put everywhere on the blockchain. And so the good thing about it is that basically people can trust this this book of transactions that is spread all over the Bitcoin network, and everybody knows that it's what is written in there is true. And I mean, until now, there's so much money in there, and nobody had a successful attack of hacking it, right? So this means that until now, this is very secure, and what is written in there is also true. And so this is basically kind of like a very large database that is spread around like a huge network. Everybody can look into these transactions that happen. Everybody knows that what is written in there is the truth. So now that you know kind of what the blockchain is, the Bitcoin blockchain, and what is stored in there, let's look what a smart contract is. So a smart contract is basically, there is now code that is written on a blockchain. So in the Bitcoin blockchain, you store transactions, right? But on the but on other blockchains, like the Ethereum blockchain or the Celo blockchain or the Tezos blockchain, you can not only store transactions, but you can also store code. And code that can also be executed on this blockchain-based platform is called a smart contract. So this is code that is stored there and also can be executed. And so now the whole network, instead of just storing the transactions, they actually store and execute the code. So this means that every computer here that is participating in the network and is a node in this network has basically a copy of the code that maybe you wrote and can execute it. So if somebody executes a code and executes a function, for example, this function then gets executed everywhere in this network, and everybody has the same state of the contract. So this is basically why also some people talk about it as a world computer, because it's basically like a very, very large computer that processes programs, and everybody knows that this is kind of the state of the program, and as everybody has the same state of the program. So like Nick Szabo, who invented the term smart contract, sometimes like talks about it kind of like that the vending machine is an ancestor of it. You probably know a vending machine, right? Like you put money in there and then you click on a button and then you get a candy out there. And this is basically what a vending machine can do, right? There's nobody in there. That's just like the mechanics of the machine that can do that. And so we can also think about it kind of less like a state transition, right? Like if you would write a program, like imagine this vending machine as a program, and then imagine different states of the program, right? Let's say this has two states now, a very, very simple program for this vending machine, and it has two states, off and on. And so if you put money in it and the state is off, then the state switches to on. And now if the state is on and somebody clicks on an item that they want to buy, then the item, the candy in this case, gets dispensed and the state switches back to off, right? And so this is kind of like a very simple state transition. Like here's one state of the program and here's another state of the program. And now in the blockchain, like imagine like having a program running on a blockchain. So basically every time that a state of your program is changed, then this state change is also synchronized through all the nodes in the network, and everybody has the same state of the program. And so this is basically what happens, and yeah, you basically also have to pay for that. So now that we have seen this as an abstract example and compared this to the vending machine, let's look into like a little bit more concrete example. So in this example, we have Alice and Bob, and they want to make a bet. So they want to bet that, for example, on December 1st, it will snow. So Alice says it will snow, Bob says it won't snow. And now, maybe before, it would be very hard for them without smart contracts and without blockchain code. It would be hard for them to make a bet, right? Because if they want to create this contract for themselves and it's a custom-made thing, then usually they would to go to a notary and have lawyers and write up a contract, and then they can say, okay, like this is the betting conditions, right? And if somebody wins, then this will happen, and if not, something else will happen. And then they also need to enforce it. Like if somebody doesn't pay up, they need to go to a judge, and so on and so on. So, but now we are doing this on a smart contract. So basically this runs on the blockchain, so then it doesn't need to be a judge. So first of all, this contract is a betting contract, right? Let's say it's a betting contract. And then Bob and Alice now both put money into the contract. So now already we could, if we imagine this state transitions, then now basically after Alice had put money into the contract, the state in this contract changed. After Bob puts money into the contract, the state of the contract changes. And now the contract is basically waiting for conditions to happen. Now, for example, let's say it was December 24th and it snowed. So somebody is right. Now the contract gets this information, maybe from an API, right? In this case, if it's from an API, then you could use something like an Oracle, which is not 100% on the blockchain. It could be gamed, but let's say if they are just betting on $10 or something, it's not worth of it to being gamed. So like they would get it maybe through an Oracle, through an API. They get the information into the smart contract that, yeah, it snowed in this case. And then the contract, so this would be another state transition. Right now, the state is, okay, this was maybe a state of one function says, okay, it actually snowed on this particular condition. And then, like if Alice said it will snow, then now she gets the money, and this is basically also just executed by the contract. And so nobody has to do that, right? So like this is something that runs automatically, and this is something that before was not really feasible because nobody would trust to write this contract, right? If Alice would write this contract for herself, then maybe Bob wouldn't trust that the contract works, or maybe at a certain point it's hosted on AWS and AWS says, I don't like that. So anyway, so like this is kind of an example how you could make a bet on that. And now the next thing that we're talking about is a decentralized application. And basically a decentralized application is, before we just talked about the code, but now we're thinking about whole applications, right? So like a decentralized application is not hosted on a centralized service like AWS, but on a decentralized network, right? So nobody, like, for example, AWS could say, I don't like your app, and we will pull it down because we think like maybe you violated our terms of condition or whatever. They could just decide we don't like this app, and that's why it has to be shut down. But in a decentralized network, or maybe they could even change something. And in a decentralized, if it runs this D-app, which not runs on a centralized service, but on a decentralized service, for that, they can then actually, it is distributed along the network. And so nobody can easily shut it down, right? If they shut just one computer down, then it could just, it's still a copy on this one, and all the states are synchronized around the network. So it doesn't matter, right? Like this decentralized application can always run. But this also means that if somebody wants to do something with voting or with money that is very sensitive, then it's very good that nobody can so easily change it. Now let's look quickly into the structure of a D-app. So you have first of all the blockchain where you can store very sensitive data. It's expensive to store data on the blockchain, so you should maybe not store everything in there, but maybe just hashes of it, or maybe just the most important data. Then you have the smart contract, which is basically like a contract that just runs on the blockchain, right? That we saw before, like the betting example. And then we have like the front end, which basically, you can use maybe CLI or maybe like just a pretty normal like HTML, CSS, JavaScript frame front end. And then you can use like libraries like Web3.js that we are using today, or ContractKit, where you can basically talk to the blockchain and talk to the contract that you have written. So this is basically connection to the smart contract here. Okay, so why would we want to write a decentralized application? On first, it's a transparent program, right? Like everybody can look into the program and look how it works. And so they can trust the program because the code is deployed on the blockchain, and it's usually it's a public blockchain where everybody can look into that. Somebody can also just fork the code and can just basically fork it and say like, hey, I want to create my own version of that. So this also enables a lot of progress and a lot of interesting developments. Then, probably the most important attribute is what we already said, like the Bitcoin blockchain, right, which stores transaction, but you can also store other important data in there, maybe healthcare data or whatever. And so like this kind of public database, which is immutable, meaning that nobody can change this database. Nobody can just change some data or read out data in another way that is intended. So this makes it also very interesting for everything that is very that has very sensitive data, right? Like if you have voting data or healthcare data or monetary data, like or reputational data, like everything where the data is very sensitive, this maybe might be worth it to store it like in a database that that is immutable and nobody can change. Obviously, the data can be public. So if you just store like health records without encrypting it or hashing it somehow, then this might be bad, right? But you can do that. And then and then the last thing is that it's not all good, right? Also, like these kind of programs are usually slow and expensive. Because as we have seen before, you need to pay for every of these state transitions, and because it needs to be executed along the whole network, this is also very slow. So all in all, there are some good things about it, some things which might not make sense to do it, but we can see that that if you really want to build something on that, you have to think about it if it actually makes sense. And that is already the end of this first very quick theoretical part. Yeah, as I said, that this is just like a quick intro. And we hope that you already know something about blockchain technology, so this is not all new to you. But if you want to, you can check out this course here, Introduction to Blockchain, where basically everything that I just covered and in a much more detail you can look up here. And you have also like very nice videos which explain the things like in much more detail, right? Like how things work. And also like you have other materials where you can learn more about it. So if you want to dive deeper in there, I would say check this out. Okay, and now I will quickly look into some questions that are here. So I saw one question of Charles here. So as he explained about storage on blockchain, it came to me to ask if this technology does eat a lot of storage in computers. Like if you have needs to record of all transactions, it will be big files to download. Yes, so you don't. So that's a very good question. So the question was basically if like here maybe we have seen that like the data of all the programs and all transactions basically. If you want to download this data from a blockchain, this would cost a lot of storage on your computer to download all this. But you don't, basically there are different kind of nodes. And like if you want to write a program for that, you don't need to download everything, right? So this is just like if you want to run a node, but you don't have to run a node to interact with it. You can also just connect to a node like through a wallet that we will do. I will show you later how this works. But to answer shortly, no, you don't have to download all the data to build something with it. But if you want to participate, you can be like also there are like light nodes where you just have where you don't download like all the data, just some of the data. But you can also have like basically download the whole blockchain and be a full node for the smart contract platform. I hope this explained it a little bit. Otherwise, Okay, maybe there was quickly like a question about how Alice and Bob can trust the program that it's expected to do. So the first question is like, why can they trust this program? So they can't. So somebody's writing this program, and the program is so they can trust them on the first hand because nobody can change the program, right? Like like obviously, or they can change it, but they can just change it how it's specified in the code. So the only way to change the program how it would work differently is if it would be specified in the code. So this is different as if you would have to trust the program that it hosted on AWS or somewhere else, right? Somebody could just write an update or a fix and change the program, and then it wouldn't run as you anticipated. So this is the first thing. And the second thing is that you can really look into the code and basically just check out how the smart contract works. And from that, you know how it's expected to work, and that you know it will exactly work how you say it is. Obviously, not everybody has always the time to check all programs, but the good thing is that there are usually a community of people, and if something is going wrong, this will be notified. The second question is how the program handles changes at the same time. Yeah, so this is basically kind of, this goes into a little bit more, this is a little bit more difficult. But basically, yeah, you would have to look into, it's the same problem with Bitcoin, right? Like how does it handle the different transactions at the same time? Maybe I send you some money and maybe 3 seconds later you send me some money and these kind of things. So like this, it's kind of a similar problem. And for that, I think you need to look into, I won't explain it here in too much detail, because yeah, this would take up too much time. You can look it up in the other courses, but basically, like the blockchain is a block of transactions, right? And kind of this is the state is also kind of a state transaction. So this is kind of also a transaction, and the miners will look into. So the people who are collecting these transactions and putting it on the blockchain, they will check that and kind of basically sort that or know what state it was. And it can handle it at the same time, and it will just yeah, it will look into what was the state at this time and then execute it accordingly. I hope this was yeah, I need to make it briefly, but you can look into also like how transactions are handled on blockchains and yeah, if you want to go into more detail there. Okay, so if you have more questions, just put them into the channel. Maybe we will come back later to that. First of all, now let's go into the smart contract programming. 1 second for that. Okay, so this is, I will make it a little bit bigger, so hopefully you can see it. So we are using something called Solidity, which is an IDE for sorry, we are using Remix, which is an IDE for Solidity. Solidity is a programming language of Ethereum. I think most of you have heard about Ethereum. It's basically the second biggest blockchain by market cap after Bitcoin, and yeah, and basically the first one where you could write like simple, where you could write this kind of blockchain code. And they have an IDE, right, like an environment where you can just like basically write code in here and do different things in there and basically just execute the code, test the code, and also like deploy them to the blockchain. So this is very nice, and it's very beginner friendly. Maybe later you will use something else. Yeah, again, we are basically doing now on the Dacade course, if you want to have more detail, we're doing this Silo development one-on-one, and we are here at smart contract development. So here we also give an introduction to Remix. You can look this up. And yeah, if you just started, you can get started with Remix by going here to Learn Neth. And then you can do like a quick tutorial where you can learn about Remix basics. So basically there you will learn how this IDE works. It's not so complicated, but basically like here you have like your file explorer where you all have all your files, and you can create new files. Then you have the compiler, which we'll use in a second, which compiles the Solidity code into like the bytecode that can be executed on the Ethereum virtual machine, where all this code is basically executed on the blockchain later. But for now, this code does not have to be deployed to the real blockchain or to the test network of the blockchain, but you can also use it basically in a virtual machine in your browser, just in JavaScript, so you can test it before deploying it. And so this is about the basic fields, like the basic tabs here that are important. that, yeah, here File Explorer, and the compiler, which also tells you if you made mistakes. And then you have here where you can deploy the contract and test it. We will see in a second how this works. So first of all, I created now a new file, which I called Marketplace 1, because in this tutorial we are going to create a marketplace DApp. Maybe just to show you what we are going to build, I will go back here to this course. So you can look it up. Here's also a trailer for that. But we are basically creating like a little marketplace. Here's a GitHub repo. And here's a live demo where you see like, hey, I first have to connect to a blockchain here. So I have a wallet. I will show you later how this works. And then I can connect to the wallet. Then I have here some money. Or in this case, I was not connected to the main network, but I want to use a test network. And yeah, and so basically I can connect here to the testnet, and all of these items, products in the marketplace are now saved in the Silo blockchain, and I can buy something here and kind of spend like money for. I can basically, yeah, just spend some CUSD token here. You will learn more about it later. But it's basically like a very simple marketplace where you can learn how you can buy something with token, where you can sell something with token, and how to interact with a blockchain. Yeah, so this is what we are basically going to build. Here's the GitHub repository. As I said, you can find it on dacade.org. Here you can look into that. And also all the code that I'm going to do, that we're going to build here upon. Like there's always, after each chapter, you can find the code here with a link to to the repository where basically the code is, and you can just copy it to Remix and then try it out yourself. So this is what we're going to build. So we are going to build a very simple marketplace. But for now, let's try to make this the very simplest hello world contract. So basically now we are starting to build this blockchain code that will run on the virtual machine on a blockchain based platform, right? So it's like this is a very first iteration where we'll just store a variable. So first of all, yeah, we can specify the license, whatever kind of license you think is appropriate for your program. Then we use the keyword pragma to tell the compiler which version of Solidity we want to use. So in this case, we say we want to use a version of Solidity that is equal or bigger than 7 and smaller than 9. And so this is basically just good to know for the compiler, because imagine that you write a program and then like in 5 years, there's a different Solidity version, and it wouldn't work with this new Solidity version because there were breaking changes introduced. So then you can basically just choose a different compiler and you can still execute the program and like if this still works. Okay, so this is basically the Solidity version that we will specify. Then we have then we use the keyword contract to create like a contract, basically this kind of smart contract that we talked about, basically this program that we are writing, right? This blockchain program. And we call this program Marketplace. And for now, this program, the only thing that it stores is like one variable, right? And this is a state variable because this is kind of what we will store in the blockchain. So this is something, this product we will store in the blockchain. So this will be our very first, very simple blockchain marketplace product code. And it's already ready to be stored in the blockchain. And first of all, we have to specify like what kind of type this this variable that we are storing should be. So for that, we will say for now it will be a string because we just want to save like a product. In our case, it's a burger, and the burger, yeah, it's just a string that we want to save, kind of like a very simple hello world contract. You can look up like the types in the Solidity documentation. They are booleans, integers, unsigned integers, which are basically just positive integers, and like a lot of other things that you can just look into. Yeah, it's also, again, like here you can find like the link to the to the types if you need it. And then we need to specify the visibility. So this means like who can access our variable, right? Like either if we put the variable on public, then we say that it can be accessed from the outside, from anywhere, but also from inside the contract. And it will also create an automatic getter function. I mean, I know that you don't know what it is at the moment, but I will show you in a second what this means. So again, like you can look into the documentation for visibility. So there's external, which can be just, the functions can be just called outside the contract, public, which means internal and external, then internal, which means that they can only be called internal and from contracts that derive from it. And then just private, which means just from contracts just from the contract and not from deriving contracts. Anyway, for now, it's good for you to know. Like, I think you can basically just to play around, you can use public most of the time. Okay, so basically, and then we need to name it. We call it product in this case, and now we assign it a value, and this value is the string burger. And that's already it. So this is our very, very simple contract that we have written. Now we can compile it, and yeah, let's see if everything works right. We have no errors. We have a green little check mark here. This means that everything went good. And now we can deploy it. So as I said, we want to deploy it to just our JavaScript virtual machine. So meaning it's just in our browser, so we can play around with it. We can also choose different accounts and do all kinds of things. But now the important thing is that we deploy it. So meaning that we usually would deploy it to a blockchain, but now we deploy it here to our own virtual machine. And here you can see the deployed contracts. So this is a contract that I just deployed, and I can open the contract. And now we said that it has an automatic getter function if you use the keyword public. And so this is basically an automatic getter function means that we can call, we can make a call to get the value of this public variable. And so this is what we are doing here. This is the automatic getter function that we are using here, and we can just use it here in this in the IDE and call it, and then we have burger. Yeah, and we see this is string burger. Maybe this looks like a little bit small for you, but yeah, but it says burger, so this worked all right. Okay, so this is the first contract worked, and yeah, this is basically, if you already have done that, then you have created your first smart contract on the in Solidity. So this would be like a very good job. I would really encourage you to try this out. Then let's say for the next part. So now let's change this a little bit. So now in this part we only have one variable that says burger, and it's just hard coded in there, right? So we cannot make our own input. So in the next iteration of our marketplace contract, we want to specify ourselves which kind of what value we want to save in our product string variable, right? So we need to create functions. So functions, it's also pretty easy in Solidity. You need the function keyword. Then you need to name your function. In our case, we name this write function where we want to write something to the variable. We could call it write product. Then we need to specify the type of the parameter. And in our case, we want to have one parameter, which is a string, right? Because we want to name our product ourselves. So this is what we need to do. And then there's like another thing that is now special, but it's, we don't get into too much details here because you also don't really need to know that too much. But basically, we need to specify the data location. So if you use something like string, which usually costs a lot of, which is pretty big to store on a blockchain, then we need to also specify where to store this where to store this data. And in memory means that it's basically just stored when we are executing it here, but it's not a state variable, so it doesn't, it's not stored in the blockchain, right? Because this is not what we're doing here. In the parameter is not stored in the blockchain. Just the variable is a state variable and is stored in the blockchain. So that's why we usually all of the function parameters are always memory, because yeah, it's just stored here. Okay, yeah, so then we name it, in this case underscore product, so we can differentiate it for our global state variable product here. Then the function is public, so meaning that we can access it also from outside. And then basically we assign our parameter here to our state variable product that we have here. And this was already the write function. Now we have a read product function. And this function doesn't need any parameters, right? Because we just have one variable here, product. So we don't need to specify which one to get. We know it's only one that can get. Then again, we say also this function is public. Then we need to we can specify if the function doesn't write anything to the blockchain, just reads it out. Then it's of type view. And so so this basically just we know then that it doesn't write anything to it, and we can specify that. Then we need to specify the return types. In this case, we only have run type, which is a string, and it will be also just stored in memory here. And we will then this function will just return the product. Basically, this whole function, we could also have not done that and just have used the public keyword that we did before, right? Then we wouldn't have need that, because this function basically does the same as the public keyword. But we didn't do that here because I want to show you how to write a read product function. And that's why we also make the visibility internal, so that we don't have two of them and basically just create our own getter function. And yeah, so you know also how to write this kind of functions. Okay, now again, let's compile it, no errors. Let's deploy it. Okay, I will delete now the first contract that we deployed. Here's the second one. Now we have we can write a string, right? Let's say we want to have an apple, which is our product. And now we can read out our product, and you can see here it's an apple. Now let's make an orange. Save orange here, read product, it's again orange. Okay, so this already works again. We got one step closer. Now let's look at the next iteration. So the next thing that we want to do is, now basically we just have one product that we can store, right? But basically our marketplace, or also if we want to have a shop, we want to store multiple products, not only one. And in order to do that, we can use something like a mapping. So basically, this mapping allows us to map a uint, basically a positive integer, which kind of function as our index, to a string, right? Which is basically our products. And so basically, we have a key value store here, and so we can get through the keys, we can access values. Then we need to specify, again, the visibility. In our case, it will be internal. Again, it has the same function. We do it again also internal, because we want to write a read product function. Otherwise, we could also have made this public again. And then we need to have a name for our mappings, and this is products. Okay, now let's look into the write function. So this time, we also need to specify an index, right? So before that, we just wrote down the string, but this time we also need to specify an index, so that we can actually add which functions as the key, and that we can actually access that. So we will use an unsigned integer for that, right? That we are using here also. And again, the string is the same as before. Again, it's public as before. And now, in order to store this product, we will store this product by creating an entry here in our mapping. So our products mapping with the key from our parameters index here, this gets assigned the value of product that is in our parameters here. And this is basically how we store like now this product in our products mapping. Now to read it out, now we need a parameter, right? Because we need to specify which index it is so that we know which kind of string from which product we want to read it out. Then everything else stays the same. And now in order to access this mappings, we need the mapping name and then the key, basically in our case, the index here. And this is already it. So now we can store multiple products. Again, let's compile that. No errors. Let's deploy it. I will delete the old contract. Zack. Now you can write a product. Let's say the index is 0 and the product is apple. Now we start our first product. The second product is an orange. Let's store our second product. Now if we look at our first product, we see apple. If we look for our second product, we see orange. Let's try a second one, a third one, which with the index 2, and this is empty. Okay, so basically we can access our products as it is intended. So yeah, this works out great. So this is a way for you to test that. Okay, perfect. Now let's go into the next iteration. So basically here we can store one product, right? But we don't want to just store like just the name of the product. So we can store multiple products, but just always the name of them. And this is basically not enough if we want to have this kind of marketplace or shop. So for that, we need to have multiple products. So let's look into the next iteration of our contract. So basically now it looks a little bit difficult, but it's actually not. So like here you see a lot of code, but so basically the new thing that we introduced, instead of having a string here, which is called, instead of having the string that we had here, which is called product, right? We now create a struct for that. A struct you can imagine a little bit like an object in JavaScript, but without the functionality, right? Without much of the functionality, we don't create methods for that or anything like that. So we are basically storing a lot of different properties inside of this product struct here. So first off, yeah, we need to specify also the types that we are going to store. So first of all, we need an address because we want to be able to pay the person who owns the product, right? So we need an address to basically like an account on the blockchain so that people can get paid on the blockchain with tokens. And then also, if somebody needs to be paid, we need to specify this with the keyword payable so that the contract is able to pay this person or this account. And in this case, we name this account that needs to be paid owner. Then we have a string, which is just the name of the product. We have a string, which is the image. We have a string that is a description. We have a string, which in this case is a location because we want to say where people can buy it. And then we have uint for price, how expensive it is. And then we have uint for sold, for how many items have already been sold. Yeah, if we look this up again, right? So this is sold. This is a location, so people know where it is. This is basically the address. If you click on it, then yeah, it will open like the address of the user in the blockchain explorer. And then here's the description and here's the name. And here's the price. And so this is basically everything that we specified we have here. Now we create a mapping, but in this case, we are not mapping it to a string, but we are mapping it to the struct product, right? So now it's just kind of the same thing, but we have now instead of mapping it to a string, it's mapping to a product. Now, if you want to write a new product, if you want to insert a new product, which also in our in our application here, you can do here, right? So you can add a new product in here. And if you want to add something new, which is basically the write function that we're using here, then you need to specify the index. So what kind of index you want to create. We need to specify the name, again with memory, and it's a string, the image URL, the description, and the location and the price. Then we also have here how many times it has been sold. But if the item is freshly created, then we will say that it's basically 0 what has been sold. And then, so this is like we're creating a uint basically automatically. The user doesn't have to enter that. This is something that we just know that it's always 0. So we can just make this just define it as 0, assign it to the value 0 here. And yeah, now we fill it. Now we fill our mapping. So basically, this index that we created before also like so we have to now we have a special method that we can use from Solidity, which is called message sender, which means that the person who who executes this function, this is message sender. And so in this case, we want to have the address of the owner, and the address of the owner will be the one who executes the contract, right? So if I add now a new product, then my address will be in there. And I will be the person who will get something if something is sold. Okay, yeah, and then we just save like everything that we talked before. Now we can read it out basically in the same way. It's pretty easy, right? It's basically the same as before. We have an index, and otherwise we are just reading like the different kind of the name, the image, and description, everything that we stored in our mapping. Okay, so this is again basically it. I will not test it here because it's yeah, it just takes too much time to do it, but it basically works the same way. We compile it, we can deploy it, and then we can enter like here everything that needs to be entered, but I won't do that here. And then in the next section, basically we will just do some cleanup work. So one thing that we want to do is not always the person does not always need to put an index in there, right? Because they don't know the index. And also we will store kind of how many products have been input, like how many products are in this marketplace stored in the contract, so that we can iterate over them in our front end, and so we know over how many products we need to iterate. Yeah, so this is what we're going to do here. So here we have basically a variable which is for how many products we have in our contract. Obviously, like if you create the contract for the first time, this will be 0. So now, now we have this variable products length, and this is basically what we are also using as the index, right? So like we have the same index as before. But this time it will not be like a parameter that is being inputted by the user, but we will just use product length. Like obviously if you create the first product, this will be 0. But then if the first product is created, we increase product length, and now this will be 1. So if the second product is being created, then product length will be 1, and so the index of the second product will be 1. And so basically like that, we count up like all the we count up our index and can get like all the values through that. And yeah, finally, just the last function that we're adding here is get product length, which is just a function which tells us how many products we have stored, which we will use in our front end, so that we know. So that we just know how many products we have and how many products we can iterate over. So this is basically it for this contract. Yeah, I mean I will not go through it. They all work. But let's look into so basically now the last functionality that we need is a functionality to make a payment, right? The most probably also important functionality, because we want somebody to pay in token. So now it gets a little bit complicated, and if you don't follow that, like I said, just go on Dacade and maybe do that again with some more time that you can look into that, because what we're using here basically is an IRC20 token. So there are a lot of different tokens that can be, you can create your own token on Ethereum, right? And this will be an ERC20 token. And we are going to use an IRC20 token, which is called CUSD. And we are basically using the Celo blockchain, which is pretty similar to the, which also has the same programming language, just is a little bit it's just a little bit different from the Ethereum blockchain. For example, it's less expensive to make transactions on that, right? It's not as big as the Ethereum blockchain, so it's maybe not as secure as the Ethereum blockchain, but like there are so many, but like if you just want to start to test out, that's really great to use, because like you don't have so high transaction costs. It's also faster, and you can use something like the CUSD, which is a special token that always has the same price as a US dollar, right? Like otherwise, if you have a shop and then the Ethereum price, maybe one day the Ethereum price is $2,000, and then the next day it's $1,000. And so like this can vary a lot on your product. So it's good to have like something like a US dollar that is stored to a certain amount. And this is basically what you can do with this CUSD token from Celo. That's something that you don't have to do, but we are doing it here in this tutorial. And so this also helps you to understand how this IRC20 token works. So basically, this has an interface here with different functions that you can use, and we will use the transfer from function, which basically allows us to transfer this ERC20 token, the CUSD. So we basically, the only thing that we change here is that we create like a new function called byproduct. So now basically we're writing the function for if somebody clicks on this button, and if somebody does that. So first of all, we need, so this is basically how we can create like a condition. So with require, we create like a condition and tell them like, hey, like if require doesn't work, we don't want to count up like the products that has been sold, right? So like this is the condition to do that. And so what we need to do is basically we use this transfer from method from the IRC20 token interface. So meaning a way how we can transfer this token, and we transfer it to message sender. So to the person like. We transfer it from message sender, so the person who executed this contract, and we will send it to the owner of the product that the person clicked on, and we will execute for the price of the price of the product that we also get here from the mapping of products with its index. And if this doesn't work, then we will say the transfer failed. Otherwise, we will transfer this token. And so I know this is a little bit complicated. Maybe you can look into that in more detail. But this is just really this one function. It's also not very big. And like this interface for this ERC20 token that you can check out. And that's basically it for our contract. Yeah, like I said, you can check out everything on Dacade and look into it in more detail. And then here's like the whole contract that is here. And here you have like the contract that you just saw. So now you can deploy your contract. I won't go into too much detail, but basically you can install a plugin for Celo. Celo is what we're using here. So you can install it here with this under plugins. Activate it. Then you have here the Celo plugin. You need to install a wallet for Celo. The wallet is basically the way how you connect to the blockchain. And in this case, the Celo blockchain. There's also a wallet for the Ethereum blockchain, but we are connecting to the Celo blockchain. We choose this test network. And then if we do that, then we can connect the account here. And now we can deploy it to the network here. So basically, this is what we can do. Yeah, but I will not do that here. Like I said, check out the course for more details on that. But basically, another important thing is that you here's also like if you compile the contract, you will get an API, which I will explain in a second, just for you already to know it's here. And if you deploy the contract to the Celo blockchain, which maybe I can just do it for fun here, that you see how it works, right? So I will deploy this contract now. Now you can see, yeah, I need to pay something for it, but since it's it's on a test blockchain, meaning we don't have to pay real money, we just want to play around with it and test it. So I can click here on confirm, and here you can see this is the address on the blockchain where this is stored. Okay, cool. So now basically we have this contract on the Celo blockchain. Okay, now let's look. Oh, sorry. Yeah, I will check quickly if there are any questions here for that.
I might have a question.
Oh, yeah. Please.
I just wanted to find out, so when the block transaction, is there like a block explorer that can be sort of like checked for after you deploy it?
Yes, definitely. So, and I think in this plug in here we don't have it, right? But if you check out your wallet, so you will always, if you use Remix, then you will always have a wallet, or you can also use Hardhat, but this goes into much detail. Just for now, like you will have like a wallet connected to it, and if you have a wallet connected to it, then usually it should also show you this on the Explorer. So I think in this case, it doesn't show me the transaction on the Explorer, but as I said, like if you click on here, you can click on view on Celo Explorer, right, which I did here. And okay.
No problem. It makes sense. Maybe just another question surrounding the code that's used. After address and payable owner, are those functions that are sort of part of Remix or like the blockchain or the Solidity language?
Yeah. Okay. Sorry. Just for your first question, just to answer that.
Sorry about that.
Yeah. So if you see like I just typed it in here, right? So basically, if you do it on Ethereum, then you will directly get connected to it, and it will show it in the wallet. But here now you can basically just copy the address here, and then just paste it in here and search it, the address. And then it will show you contact creation successful, and you can see, okay, here is the contract, and then you also get the compiled bytecode, right? Which might not help you a lot, but yeah, you can see that it's here, and this is your contract. You could even compare it to your code, like if you compile it here, and yeah, then the bytecode will look the same that you can copy here. Yeah, to your second question, so like basically all of that we are talking about here is not all we are writing in Solidity here, so everything is part of the Solidity language. So if you are looking for like this payable keyword here, then you can just go to the Solidity documentation and go payable. And yeah, and basically, yeah, and then you will find explanations for that in here. So like in the documentation of the language, you can find that. You can also see they also recommend like Remix here, right? Like in the Solidity documentation. Maybe like if you go to Solidity, always check that it's the latest version, because if you Google it, then it usually just shows you some. But yeah, but basically, yeah, like it's all part of the Solidity language. You can look the keywords in up here. Okay, so okay, I would say for now, let's move on since we don't have so much time. But I will look into the question. Just put your questions into the chat, and I will answer them later, or like also in the chat at some point. But now, yeah, we basically have created this contract that we are going to use, and you said you saw that I deployed it, and also I showed you that here is basically where you can also get this application binary interface that you can copy. This is what we're going to use in a second, and yeah, I will show you how. So again, if you want to look into into what we are going to now, we're doing this building of the front end. So basically now we want to interact with it. Yeah, you can clone, like here, a boilerplate web dep for Silo, which basically has everything that you need. Already Web3 and contract kit installed, so you don't need to install anything. You can just clone it and then just install it and then run it with npm, and then you can basically start. Okay, but yeah, you can also just check out the code here and get the repositories, and then you have everything that you need. So I will very quickly go through that. I think it's, yeah. So first of all, I think so yeah, maybe first of all, like to show you, yeah, we are basically like building it with Webpack. So we have, like, most importantly, we have our index HTML here, and then the main JavaScript file here, main.js, which is probably the most important one. And then we also have, I stored the contract in here, which you don't have to do, but it's nice to always have it here. And then we have like this application binary interface. Basically, it's just a JSON that shows how to use the smart contract functions, and basically that tells your JavaScript how the contract, what kind of inputs and outputs the contract has, and how it can interact with it. So this was what I did when I clicked on copy here, copy ABI, which is basically an interface, and then you can just paste it in here. And so I did it here for Marketplace, and you can do the same then also for the interface here. But basically, I think in the boilerplate we already have this also. So if you don't change anything, the ERC20 token interface you don't need to change, and this your own contract interface with here you can change if something changes in there. Okay, so this basically here, this is what we have under contract. Then let's go quickly through our HTML, which is pretty easy. We are just using a different font here. We are using Bootstrap icons in here, and we are also using Bootstrap in general. Bootstrap is basically just a very simple library which makes which gives you components of buttons and all kind of UI elements, just so that you can get started quick and don't need to code a lot. Then, I mean, the style we adjusted just very briefly here, not with a lot, right? As you can see, we basically used everything from Bootstrap. Then the only thing that we have basically here in our navigation bar is the name. Then we have like a span element with the ID balance, which basically just shows the balance. Then we have like a notification, like a div here with a notification, with a span, with a notification, with the ID notification, where we can put all the messages for the users. And then we have a button here which says add product, which basically triggers a modal. And then here we have the modal with an input field, so people can add like the new product, right? If you look back at this again, then yeah, here you saw this is a notification, this is a button, this is a balance, and this is a name. And these cards we will build in our JavaScript. So this is not even something that we're going to show you. that we don't that we even have in our index HTML. So we are using no framework, just vanilla JavaScript. And yeah, like here you can see, like we're getting a library called blockies, which is basically just a library so we can make like addresses to this nice little icons, so people can immediately recognize that people are the same sellers, which would be more difficult if we just have like addresses. Okay, so yeah, that's basically it for the HTML that we have here. Now let's look into our JavaScript code. First of all, what are we importing? We're importing Web3.js. So Web3.js is a library where we basically it's mostly used for Ethereum. So if you look for Web3.js library, um, yeah, you can read the documentation here, and you can see like it's the Ethereum basically JavaScript API. So you can, this has everything to interact with your contract or with the Ethereum blockchain in general, right? And since we are using Silo here, but Silo is pretty similar to Ethereum, and that's why we can also use here this Web3 library. But then we have some special functions for Silo, and for that we are importing the contract kit from Silo, and yeah, that's basically what we are getting here. Then we have big number JS, which is just a library which helps us to convert like very large numbers that we are having if we're interacting with blockchains. And then we're importing kind of this ABI that I told you before about. So this is what we're storing here. So this is basically the interface, the JSON of our interface, so that we can interact with our contracts in JavaScript, right? So we have like both of for one is for the ERC20 token in general. This is basically this ERC20 token. It's not something that we have created. It's just a token that we are transferring. And since this is a Silo CUSD, this is what we're doing here. And the marketplace ABI is our own contract that we have written. Then we are just saying, okay, like how many decimals we want to change. Like I said, these are very large numbers. So we want to make it easy for the user so that it doesn't say like 1.000000, 18 zeros. Instead, we just say like, hey, we will have 18 decimals. Then we will have like a constant for our contract address of the marketplace contract, and we have a variable for the address of our CUSD contract. Okay, so now we also create variables, lets that we will change, like global variables for kit, which is basically this contract kit that we are getting here. Then for the contract, for the marketplace contract, and then for products where we store an array of products that we basically will get through calling the blockchain contract, so we know how many products we have, and then we will store all of these products in this array, so we can then later display them on our front end. Okay, so now the first most difficult function maybe. So we need to connect to our wallet, right? So like you saw here, what people basically. So now I'm connected to our D app that I've created here. And so that's why I see like all the products and I can buy something. But if I'm not connected to it, then I can basically, then I won't see anything, right? So like if I go out of that and I refresh the site, you will see, hey, you need to approve this D app in order to use it, right? So now if I approve it, now it goes back again, it shows my balance and it shows the product. So basically people will need to, this is what we are doing with this connect wallet functionality. Okay, so yeah, so we have an asynchronous function that we call connect wallet. Then like if somebody doesn't have this Silo wallet, which we can check with Windows Silo, if they don't have it, we will show in this notification bar, please install this Celo extension wallet. Then if they have installed it, then we want them to enable it. So this is basically what I did with entering my password and enabling it. And so yeah, basically we do this. We are waiting for, like, so if this is not, we will have like this please approve it notification. But yeah, if basically it is enabled, and this is what we get through Windows Celo enable. So yeah, through await, basically we're waiting until this is happening. If they enable the wallet enables the connection to the DApp, then we will turn the notifications off. And we will create like a new variable, basically an object called web3, that we can use to then create our kit, basically, that we have created here. And this kit basically has all of the functionality that we need in order to interact with the Celo blockchain. Yeah, and so basically the first thing from the first method that we're using here is this web3 as ETH get accounts. And through get accounts, we can basically see, hey, we have gotten back this kit object, and we can use get accounts to know like what accounts are connected here. In this case, we have this account which is connected to it, right? I can also connect here to another account. If I then reload the page, yeah, you will see, okay, the balance is not updated yet. But yeah, but you can also connect to different accounts there. Basically, it always gets the default account here, and this is basically the account that we get, and this is basically also the address that we get. So basically, this is in this case this kind of this kind of balance, and it's basically 1 CUSD that we're having here, right? So you can see like, hey, this is 1 CUSD, and this is also almost 1 CUSD. So this is why you can see that. So this is this is basically the account that we have connected to, and now we can also get the contract. So basically, this marketplace contract that we use, we can use like here now the methods contract, and we need now as inputs here we need on the one side as parameters this method has the API, right, that we have here, so that the interface to interact with the contract, and then the contract address that we had stored here. And now we basically have the contract. If something goes wrong and we catch an error, then we will display an error. And this is basically what we did with Connect Wallet. So yeah, so as soon as the page has loaded, we get this, we show the notifications here, and we show the Connect Wallet function that we will just use. Then the next thing that we are doing is to get the balance. Again, we are using here like the get balance method. It's also again an asynchronous function, and we will basically just show the balance. Then this balance, we have here the total balance, we will shift it a little bit, so just not to make it very ugly with its 18 zeros. We get rid of that, and then basically we'll just show it in our balance span with the ID balance that we talked to before, right? So this function basically shows then the balance that we have here. Okay, so this is done after we have connected to the wallet. And yeah, then the next thing that we have here, so basically when the page is loaded, is get products. So if a user clicked, so yeah, after the page is loaded, then we have this asynchronous get products function. Again, it's an asynchronous function. So in this case, we're using like again the await keyword because we don't want the code to proceed unless yeah, we get some value back here for product length. And we are using the methods get product length, right? So this is basically now our contract method. And this is a method we can use our contract methods. And so basically, yeah, you remember that we created like our contract variable here, basically here through the ABI and the contract address. And this now means that we can access all the methods that we have created in our smart contract, right? So we have one method called get products length. That if you remember, it's this one, right? Which just gives us back the value. And yeah, and basically we can just call this function. We don't need to specify any parameters because yeah, because we just it doesn't need any. And now we store this in this constant products length. Then we create like a new array called products. Then we will iterate over product length. So basically we will loop over all products that we have created. Now we create basically a promise that needs to be resolved, and for yeah, and for every iteration, basically we are calling the method, the contract method read products, always like with the index of our iteration that we do, right? And we read out the product, and then if the promise is resolved, we get like the different properties that we need now, like the different for the values for the different properties, for index, for owner, for the name, image, etc. Like the price, it's a little bit tricky with a big number. But basically now we created this product, right? And in the end, we push this product, and now we have in our products array that we have here, over every loop, we add the different products in here. And then when we have all products, basically, here with promise all, if they all have been fulfilled, then we yeah, then we basically specify that here our products array that we have here, that this gets yeah, this gets all the products that we have here, and then we will render all the products. So render, then we will execute the render products function, and the render products function, I will go into that. It's basically just JavaScript that we are doing here, but basically we are rendering for each product, like we're creating this HTML for each, and then we are basically creating for each product, we are creating this card, right, that you're seeing here. So this is what we are creating for each product. 1 second. Yeah, with the image, with how many times it has been sold, the owner, the name, description, location, etc. The price, which is in the buy button, and then this little identicon has its own function, so that we can basically just create this little icon in here. But it's all JavaScript, so there's nothing new in here. Yeah, and this is basically how we got the products. Now we have like a new product function. For that we have a new button, right? Like we said, like, hey, we will have all these input fields of the modal that you saw. And then we are basically executing this contract methods again from our contract. We're using the method write product, the one that you saw. Like we are basically getting like all the parameters that we are having here. And we also need to specify from where this comes from. And this is like the Kit default account. So the address, basically the address, the contract address that we have gotten before when we connected to the wallet. So this is the wallet address of the user. And this is the person who sends that. Okay, yeah, after we have done that, we use get products again, so this get refreshed. And then we have one last button, the buy button. And here it's, yeah, it's a little bit, because we want to use vanilla JavaScript here, it's a little bit tricky to get this button right. Yeah, but basically here with this query selectors, that's how we did it. And yeah, and then we are using basically here this proof function, this function. Basically, this is again a little bit more complicated, but through that, basically, we are telling the user using the contract tells the contract, hey, I approve that this amount of tokens can be executed from the contract. And this amount of tokens is the price of the product, right? So they say, hey, contract, you are allowed to execute that. And then we use the by product method. Again, we say like we need to put in the parameters. In this case, it's the index of the product that the user wants to buy. And we need to say and we need to say from which account this is executed, which is again this kit default account that we stored initially. And yeah, and that's basically kind of it, I think. Yeah, basically then we have like very simple functions, right? Like here just our notification, which just the notification function, which just shows the text in there, and then a notification off function, which just turns the notification off. Yeah, and so this is basically everything that you need to know. So as I said, you can look into the into our course on Dacade. Everything is explained in more detail. But important for you to know is, I think, that yeah, we got the contract, and then we're basically executing this contract methods. So the most important part is how we connect to the wallet and how we execute then the different methods of the contract. Yeah, so if you would write that in Solidity, it would be like a little bit, or I mean, if you would connect to the Ethereum network, it would be a bit different, a little bit easier, because you didn't need this ERC20 interface. But if you want to do something with ERC20 token, that is good to do. And also, if you later will build this on Celo, then this will be like the transaction fees will be a lot cheaper. And this means that your users don't have to pay maybe $5 or anything to interact with your contract, right? Which might be a little bit high. Okay, so now I would say we are basically done. So we are in time. I would open it now for further questions. Maybe just one last time. Sorry, one more thing. So these are basically everything that, as I said many times, you can find everything here. The code and everything. Also, like we show you how to deploy it to GitHub Pages, like we have done here, right? So you can even host it there. So this is nice. And now there's something that is special about our platform, which is that you can also earn tokens. So basically, here you can, in this for this course, you can earn $100 in CUSD token, which you can exchange against real money at whatever exchange that you like. But you can earn this 100 CUSD if you do like a good submission, right? So basically now you have learned how to build, or maybe you do the course again, and then you know how to build a decentralized application. But now you have basically a challenge where you can earn this 100 CUSD, and you can do that by creating like by changing the contract code, by changing the front end a little bit, and by making sure that everything works. And here, like, here's how we rate that. And if you if you gain like at least 70%, then you can earn something, right? You can put in your link to your GitHub repository and your submission text, and then you can earn something. So we already had like people, yeah, here you can see like here, like 2 days ago, somebody submitted, 3 days ago, 5 days ago, and here already are people who earned something. And then the next thing is that you can also not only earn money for giving this submission, also other people will give you feedback on the submission in the form of GitHub pull requests, like here. So they help you also to get better, and you will and these people can even earn money for doing that. So the best so basically the best submission here, as the best feedback gets, in this case, like $24 for like giving good feedback, and the second one gets $8. So basically you have again also chance to earn money for giving feedback. Okay, so this is basically it. So I encourage you to do the course, to check out the platform, and to submit something. And if you have any questions, you can post them in the Dacade chat, or also, yeah, we will have, beginning next week, we will have basically this kind of co-learning sessions where, yeah, you can also just, we will code along, and if you have any questions, you can just open your mic, maybe share your screen, and let us know if something is not working. Okay, so now I will look into the questions that Natanya gathered for me here. So thanks a lot, Natanya, for the help. That's really great. Um, so yeah, so the code or the repository for this code is everything is on Dacade, as I said. So basically, just go to this here, this community, and you will see all of the code. Yeah, so maybe for the first question, you can find the GitHub repos in here. So yeah, like if you have, so through every step that I said, like I encourage you to actually like every time you see, can click your code for the section, and if you click on it, then you will see the code here, and then you can just copy it into Remix, and then you can just try it out, and yeah, and just try it for yourself, right? So I think that's the best way to learn, to follow that, and then just to check it basically out and see if everything is working there, and basically learn through trying out. Yeah, so the same goes for all code, everything is here. And also you can find the whole repository in here. So basically just click here, and then you find the final repository with the contract and also like the front end. Okay, so yeah, so the next question was why this index uint parameters are not memory parameters. So the thing is that this is so basically a string is just a certain kind of array. So like in a string, you store like a lot of information, right? So this is quite big. And if it's quite big as a string, then you need to specify the data location. But if it's like kind of small, like uint or integer, then you don't need to specify it. Let me see if I can find this in the documentation. Okay. Yeah, sorry. Yeah, but basically, so I will share with you the code to the link to the Solidity documentation to the right to the right passage. But basically, it is like I said, because yeah, for uint and int, you don't need to specify it for strings, and for bigger data structures, you need to store it. Okay, then how expensive it is using DApps in comparison to centralized system? Is there a comparison in percentages? So the thing is that it's very hard to say how. So also it's expensive for you users. It's not only expensive for you. For you, it's not even that as expensive, right? Because you don't need to pay something for hosting. What you need to pay for is basically for deploying the contract and then for interacting with the contract. So every time there is there is like a state transition, then you need to pay for that. So this means your users have to pay. So every time they interact with it, they have to pay something, and this can be quite expensive. Yeah, maybe we can find the transaction cost of transaction cost of Ethereum. So here it says like $4 42, but this is basically just for sending some ETH. So depending on your contract, so it really also depends on how complex your contract is, right? Like how many things have to be stored. So that's why you also always want to store as little as possible, because it also depends on how much like you want to store, but then also like on how much how much computational effort has to be done, and this is kind of what also costs something, which are like the gas costs, which is a little bit more advanced concept, but I really encourage you to look this up if you want to learn more. But yeah, basically it's different to AWS. Every time that a contract is executed, it has to be paid at, and the users have to pay it. So usually the users have to pay it if you don't build a kind of very complex contract to do that differently. Or you pay for your users, also something that you could do. But in general, like the users have to pay, and it's a lot more expensive. So I don't know, like maybe like if you are lucky, like a very, very cheap contract transaction could be something like $5, right? But if you imagine like every time a user uses your app, it costs $5. This is very expensive. If you do it on Ethereum, on Celo, I don't know, but it's a lot cheaper. Maybe it's just a couple of cents on Celo. So this depends on the blockchain platform that you're using. How many contracts can we have on an e-voting application? I don't really know what that means, but you can create like as many contracts as you like, and contracts can also interact with other contracts. So like a contract can call a function of another contract. So you can create like, I would say, unlimited contracts, and they can all interact with each other, and you can create a voting application through that if you want to. Yes, you can create like a framework like React or Vue for your DApp. I think that's also a very good idea. We already, so this is another question. If the question was if you can use a framework. So if you look into the submissions that we have on Dacade already, there were a couple of ones that were created with React. I think like this one, for example. Yeah, so somebody created like here, with React, and even hosted it on Heroku, so you can do that too. So then was the question if this app is not hosted anywhere. So that's a good question, because like it's a decentralized application, but basically only, or it depends, you can also host it in a decentralized manner, but this is a little bit more complicated. But the most important part basically is that kind of the server side code, right, the backend code, that the most important ingredients, or like the most important data that is basically stored on this on the blockchain. And so that's why it's decentralized, because the data is stored there. Obviously, you don't have to store all the data there. Maybe like you just have some things where you just have some text or some images that just your application wants to store, then maybe that doesn't make sense to store it in the blockchain. But maybe just the most important user data, maybe just reputation data, or if you create a decentralized Twitter, maybe only the tweets or something like that. But you can also even host your app in a decentralized manner, like something like IPFS you can use for that. But there are also like other things where you have basically the possibility to also host your app in a decentralized manner. But at the moment, maybe this is not so important. I would say the most important thing is that it's really that the most important data is stored in a decentralized way. What is the relationship between blockchain and Solidity was another question. So basically, Ethereum is a second generation blockchain, I would say. So basically, it's Bitcoin. So basically, the Bitcoin software created the Bitcoin software created kind of the first blockchain for Bitcoin transactions, and then the Ethereum software created like kind of a new blockchain just for these kind of for running like a virtual machine, to have this kind of blockchain platform where other people could execute code. And this is basically and this is another blockchain, but which executes and can store code. And in order to write kind of high level code for that, so basically on this virtual machine runs bytecode, but like this is very low level code which nobody can write, right? Like you saw how this code looks like. And so you have a high level language to write this kind of bytecode, that you can high level language that you can compile to this bytecode, and this is what the Solidity language is. Basically, yeah, a high level Ethereum language that you can compile to Ethereum bytecode, and that you can then run on the blockchain. Okay, I think I got all questions that were written here. Maybe I can open some. If somebody wants to say something or ask any questions now, also verbally, then you can join the voice chat. Yeah, maybe we need to.
Probabilmente we do contract we want to anchor the but for the hosting, buying a space, we don't need the
Okay, yeah, let me know if somebody has a question. There are some people muted because they seem to talk to other people, or like they have kind of voice problems. But yeah, if you want to say something and are muted server side, then just let us know. Just write, hey, I have a question in the chat. Otherwise, I would say, thanks a lot for coming. I will wait a little bit longer if you have any questions. Also, you can just ask the questions like later, still in this chat, right? The good thing is that we have this kind of, that's why we also do it in Discord, because you can always post questions. And if you have any questions, then we can just answer them also later. Yeah, so if you have any questions, you can write them all the time. You can, just check out the course again here. If you want to, next week we will have a co-learning session where you can also ask questions. We will also probably will do kind of the same course that we did today next week again, just for everybody maybe who just wants to join there again too. Or otherwise, yeah, just ask questions. We have also the Discord channel for Silo Development one-on-one, where you can just ask like questions related to Silo, to this course. Yeah, say hi in the introduction channel. Ask me always, or Natanya, if you have any problems or any questions. So let me look up like the last questions maybe for today, basically the final round, if you have any more questions. So do you always have to create a wallet before you can store your data on a blockchain? So we are now using here this IDE, right? Like this interface. And if you want to store it through that, if you want to interact with the blockchain through that, then there is, I think, now also a new possibility to use something called Hardhat here. but I won't go into detail here. But if you want to interact with the blockchain here, then you have to create a wallet to do that. Basically, this kind of web wallet. You can also use the MetaMask wallet for that. Oops. Yeah, so basically you have also MetaMask when you want to interact with Ethereum. So this is basically the wallet that you need to interact. But there are also ways where you can use like there are other tools, like for example Truffle, which you can use, which is more like if you are already like a little bit more sophisticated, then you can use like Truffle or Hardhead. Okay. But yeah, Truffle or Hardhead, and this basically is a suite which helps you like to create smart contracts and especially like to test them and makes this very easy. And yeah, and then basically you can also just interact through your command line interface, and you don't need to have an IDE, and you don't need to have this kind of wallet. But if you want to deploy something to the blockchain, then you usually you need to pay something for it, and also there needs to be basically an address that deploys this contract, and so that's why you always will need to create an account, but you don't need this kind of web wallet that we have here. So you don't need that. You can also create it just through your command line interface, for example. But you need to create some kind of account and make a transaction to deploy. Okay, some last minute questions. Do you need the knowledge of JavaScript and other programming languages before you can understand Solidity? No, you don't really need that. But if you don't have any programming experience, I think maybe it's not the best thing to start with Solidity. I would say like, hey, start maybe with JavaScript so that you really that you can test it easier and just you learn like basic programming concepts. So I would not say it's a good way to start with Solidity. So yeah, I think and also like if you want to create some interface, it's nice to have some JavaScript knowledge or some framework like Vue or React. Then can one connect blockchain to other databases? I mean, I don't really know exactly what you want to do, but obviously, like you can, you definitely can just. I mean, you can create a DApp, and that DApp can maybe store something in a MySQL database. Like maybe just want to store like the images in your database because they are not important. Or you can also store like some data in the MySQL database, and then you can make a hash and store the hash in the smart contract. So yes, I mean definitely you can you can basically connect them or build something to connect them. There are probably also some frameworks who help you do that. But I'm currently not aware of which one to recommend there, but probably it exists. What platform can I use to do blockchain? I mean, I don't know what kind of platforms you mean. There are obviously like different kind of blockchains. So if you mean a blockchain platforms, if you mean blockchain platforms like we talked about Ethereum, then there's definitely like Ethereum that you see here. Cardano is there. Polkadot, Solana, Ethereum Classic, Stellar, like there are like really a lot of platforms that you can do. We are like doing on Dacade you can choose there's like a course on Eternity, there's a course on Silo and also kind of basically Solidity. and then you can also earn. And then we will also have a new platform which is called Dacade, and there you can learn on even like use a different platform called Tezos, where you can also build smart contracts on. This is but a little bit more difficult. From a complete beginner with a little bit of programming language skills, how long it takes to get employable skills. Is there an average time for yourself, for example? Yeah, I mean, this is a little bit, if you really have like little programming skills, then I think it probably takes really probably a lot of time to get into smart contracts, because like they have to be very secure, right? If you make a mistake in there, like we said, the code is immutable, so nobody can change it. So so that's very, very important that the contracts are secure and you don't make any mistakes in that. So I would say it takes a really long time if you don't have any experience. So I would say it's better to just maybe learn first just programming and in general, like learn something like JavaScript code, JavaScript framework, or if you want to do some backend code, learn like whatever language you like there. But yeah, I would say it's probably with very little programming skills. I think it takes a very long time. I don't know what the average time is, and I think it's very difficult to say a time there. But I mean, if you are very good, then you can already start to earn money on Dacade by giving other people feedback. Or you can also, like, if you really put yourself into that and build something with other people, you can also create a project and with other people together, and then maybe apply for funding for that, right? Like maybe a pilot and build your own things. So you can like there are ways where you can like kind of earn money with that, but until you're really like employed by somebody, and if you don't have any prior programming skill, I would say this can take really some time. Depends also obviously on how much time you put in there. So I think it's very hard to make a time estimate there. Okay, I see that there's still some questions coming, but I would say, yeah, I will, if there are no other voice questions, um, yeah, there was noch a last question, which is like, what tracks will you recommend to follow to be an expert in blockchain, say for someone who's already comfortable with JavaScript? Yeah, so I mean, I can give there like a little bit, we can recommend there more learning materials. But basically, yeah, I would encourage you to on Dacade at least first do this Cello Development 101 course, right? So you learn a little bit about Solidity, and we can show you then like some more learning materials that can help you to get better on that. Yeah, but there will hopefully come like a curriculum on how to get better in the future. But like for free learning materials, I don't have a collection there, but I will try to gather one and then also update this answer. So for now, I would say start with this course, and there's also Crypto Zombies, which is nice for people to get started. There are like I think there are even Coursera courses that are pretty good. Yeah, we might make like a list of recommendations. That's a very good point that I don't have at the moment, like a concrete list on what to do. But basically, yeah, try to build a lot of things, and there will be a lot of opportunities where you can also like maybe get some funding for an idea. Okay, yeah, thanks everybody for coming. That was really nice. I would say check out the Dacade course. follow up on our Discord if you have any questions. And yeah, maybe see you next week, either like on Thursday from 4 p.m. CEST until 6. We will basically on Thursday have a little co-learning session where you can just, maybe it's a good starting point for you to start to do this tutorial by yourself. And if you have any questions, you can ask me and I will be there too. Or next Wednesday, we will do like another workshop, kind of exactly like this actually. Yeah, thanks a lot, everybody. I really appreciated that you had the time to come. And hope to see you soon. Hope to see your submission soon. Until the next time. Thank you. Bye.